highest paid salaries are for a lot of our sustainability engineers. And most of them are either chemical or mechanical engineers. Sustainability engineers, that's the code words that you look at every day. So today we look at one of the problems. What is the, if you want to calculate, what is the average temperature of the Earth? So shall we calculate that? So we know that there are so many planets there. Let me not go into astronomical aspects of it. All that we will concentrate is the Sun. And the Sun has a diameter of 0.39 times 10 to the power of 9 meters. It is upper the diameter. And we know the diameter of the Earth is actually 2.27 times 10 to the power of 7 meters. So you can calculate to know what the diameter of the Earth is. And normally we measure what is the solar radiation that is coming from the Sun. On the surface of the Earth, actually on the surface of the Earth there is a lot of absorption of the radiation because of the atmosphere. And you have heard about in the earlier days we used to call what is called the ozone depletion. Ozone depletion was probably that was the topic of choice before you were born. First actually they became ozone depletion, then actually global warming, then we are talking about the climate change. And they are saying that the oceans are expanding in such a way that most probably you don't know. By the time you finish ocean, you may have a beach in Ananthapuramu. Okay, that's what sea levels are rising. So maybe there will be a beach in Hyderabad also. I asked you not to ask me this secretly. Come in. Don't ask me. Don't ask me. Just keep walking. After the interrupts me. So let's global. Let us see what's happening. Now, usually India is one of the leading countries where we lost it. Once upon a time, we used to get all the data from the satellites which are launched from the NASA. Today, India is one of the leading countries that actually all the astronomical data. So when you put a satellite and outside the Earth's atmosphere, if you measure what is the solar intensity, you can have solar flux meters, and it approximately about 1368 watts. He asked me what is W. W stands for watts. So usually in as I mentioned, we give most of the units are given names of one way. Capital W is actually stands for watt. James Watt, then J stands for Joule. N stands for Newton. Of course, meter is meter, kilometer is kilometer. Okay? And as I told you earlier, they say the degree Celsius, the C stands for Celsius. And that is just is Newton. Okay, so the Newton meter, actually one Joule is nothing but 1 Newton meter. As most of you know in your physics. Newton meter. Watt is nothing but Joule per second is watts. And also you can put watt. And also you can put Joule, because it's joules per second, you can call this one as watt second. All of them are capital. W capital, J capital, N capital, C capital. This also is capital. This is what capital. So in that one, do you understand? W stands for watts. So many watts per meter. So all this power is in terms of watts. Energy in terms of joule. More often, the students get confused between energy and power. Both of them are completely different. One is what is energy? What you measure in your house. Let's say the meter. What do you measure? What are the units? Could be units and are consumed 120 units. 1 unit is about 12 rupees. If you consume more. What is the unit of electricity? 1 unit and electricity. What is that unit? Is it energy or is it power? When you buy the bulb, you get how do you specify a bulb? You want 20, 30, 40. Is it watts or is it joules? What is watts? 20 watt bulb, 30 watt bulb, right? The 100 watt bulb. Like you are always brilliant, you are equivalent to more than 100 watt bulbs, all of them. So, but bulb is actually what? Is actually power it consumes. And how much energy it consumes. For example, if you go home and because nowadays the sun sets at about 6:45, so if you turn off the lights at 7 o'clock in the evening, and also if you turn off the light at 10 o'clock, of course you are paying your own house. So 3 hours, if you are using a 100-watt bulb, how much of the energy consumption is there? 3 hours, 100-watt bulb. That is, how many watt hours it is? 3 times 100. If you need such a long time to calculate, time of response, guys, you have to tell me what is, how much of power you are consuming, how much of energy you are consuming. A 100-watt bulb operating for 3 hours, how much you consume? 100 times 3, huh? No, it is 100 watts for 3 hours. So 300 watt hours. Okay? 300 watt hours is nothing but 0.3 kilowatt hours. At the rate of how much we pay, sir? Now, what is the electricity cost? 12 rupees per kilowatt. I know they don't pay. In fact, their mom and dads, they must be paying their electricity.
Sir, it's, I think it's around something like 8 to 9, sir.
8 to 9. Okay, let's round it up to 10. Anyway, with the new government coming in everywhere, energy costs are going up. So 10 rupees, unit is actually 1 kilowatt hour is equal to 1 unit is equal to 1 kilowatt hour. That is equal to 1000 watt hours. So if you have burned the 100 watt hour for 3 hours, you have consumed how many? 300 watt hours. How much money will you be paying for that? Come on, guys. It's 10 rupees per kilowatt hours. How much will it be for the 300? Huh? How much, guys? And the back pages usually goes higher. It goes how much money will you pay? That's what I'm asking. So 300, every day you burn your you are paying about 3 rupees for the power. That's what is the, that's what I wanted to get to the units of it. This is actually you pay for the energy consumption, not the power. Okay, just you have to know. Okay, now let's get back to this one. So this is actually, now when you put a satellite and you measure, they measure the intensity. They are what is called the heat flux meters are there. Heat flux meter, they measure how many watts per meter per area square meter, how much of energy is, how much of power is available. It is actually 1368 watts per meter square. Okay, just imagine this situation. Here actually you got the sun and Earth is here. So sun to Earth, you enclose a sphere there. Okay, the sphere has got a radius of 1.5. The center of the sun to center, the center of the Earth, that is 1.5 times 10 to the power. That is from the center of the Earth. This is this dotted line. That's from the center of the Earth. Now let's assume that. Earth is going around the sun in a circular. For the time being, we assume that it's not exactly circular, and that's exactly the reason why it's not exactly 1368. It keeps on changing. Day to day and month to month it keeps on changing. So this distance is 1.1 meters. Now this is actually being measured. This is all is measured. Now from this data, I want you to calculate what is the emissive power of the sun. How do you go about it? So as you know, sun is a powerful source of energy. That's what you have been told right from your elementary school days. Nowadays, now I want you to find. Now, this G, 1368 watts per meter square, is over the entire. This is the sun, the electrosphere around the one. Every square meter of the sphere surface, you are getting 1368 watts per meter square. So, how much of energy is under the whatever is coming here is actually coming from the sun. Because let's assume that there is no other planet which is actually getting the radiation. It is also true. because the sun is so powerful that you don't have to worry about the radiation coming from other planets like Venus or Mercury or Mars, and completely ignored it for the time being. Okay. So what you have to do is you have to calculate what is the surface area of this sphere. And this is something we are measuring, although it is in the outer space, in this particular case I am taking an assumption that there is an absorption of radiation in the atmosphere. Because I haven't talked about absorption of radiation in absorbing media that I will do in the next week's class. So assuming that the entire electricity is incident on the surface of the Earth, now I have to calculate how much of radiation is incident on it. How do you do that? Okay, now this 1.5 to 10 is center to center. What we are worried about on the surface of the Earth. So what will be the sphere radius? What is sphere radius if it is on the surface? How much is it? This distance is 1.5 into 10 to the power of 11. Diameter of the 1.27 into 10 to the power of 7. I will put this distance. How much is it? It's not there on the board. You have to calculate that. Okay, how much is this distance? Center of the Earth. This is surface of the Earth. This is center of the Earth. This is the surface of the Earth. Okay? Let's say that this is the diameter of the Earth. The distance I took to the Earth. How much will be the distance? That will be equal to? How much will be the distance? If the diameter is 1.2 and 10 to the power of 7, what will be the radius? The diameter is, if the diameter is 2 meters, what will be the radius? 1 meter. If the diameter is 1.27 into 10 to the power of 7, what will be the radius? 1 half. Tell me how much is that? 0.635 times 10 to the power of 11. So this is it. Now this distance is 0.635 into 10 to the power of 7 meters. The distance 1.5 10 to the power of 11 is then all that I am asking is how much is this distance? That will better in the Ananthapuramu నుంచి పూర్తి 50 కిలోమీటర్లు పూర్తి నుంచి 20 కిలోమీటర్లు అనంతపురం నుంచి In fact, you will see that it won't be much different. Remember this, I wanted to be magnitude 0.637 subtract it again, it doesn't make any difference. So it will be more or less same as 1.5. That's what is the point I want to drive. If the very large distance, if you take out a small distance, it doesn't matter. For example, to give you an example, Ananthapuramu, I don't have the same. Ananthapuramu to is say about 50 kilometers. Ananthapuramu Mapu నుంచి కొత్తూరు 2 kilometers, 1 kilometer, say for example. Really it doesn't matter 49 or 50, it doesn't matter. Here is you see 10 to the power of 11, there's 4 orders of magnitude, it really doesn't matter. So you will be quite safe by assuming that the surface of the Earth approximately same. Even if you do the calculation, it won't be completely. So now what I want is I want you to calculate the radius of a sphere which has got the surface area of a sphere which has got a radius of 1.5 meters. And out of take out 0.65 into 10 to the power of 7. So this is the radius. Right. Geometry. What is the surface area of the sphere? How much is that? Surface area of the sphere. What is surface formula? What is surface area of the sphere? R by d squared. 4 by r squared or 5 d squared. Does anyone remember that? Surface area of sphere you would have done in your 8th class or 9th class. About me, Mundu Chalvina, I can't teach you high school mathematics on that. What is surface area of sphere? 4 by r squared. R only 4 times 5 times 9 multiplication. So in this one, you will be not safer, you will be calculator. It will be a huge number, don't worry about it. They will tell you what the power of everything. 4 pi r squared, that is the area. So on the area part of this one, that is the amount of this. What is the total power coming out? That is, this is per meter squared. You know the area of the sphere. So you find out what is the total irradiation coming from the sun. Not it, it's total irradiation coming from the sun. Which will be nothing but 1368 multiplied by 4 pi times that square. You have to tell me how much is the number.
So should we take off the area or full area, sir? Because only half portion of the globe is exposed to sun.
The whole surface area, this is sphere.
The other part of the planet is dark, sir. It's not
this is
received.
no. The other part of it, so we are talking about the surface of the Earth.
Okay.
So what is coming out is the sun emits radiation in all directions from the sphere.
Oh, radiation.
It's not dark on the other side. Sun is spherical.
Okay.
Like a bulb. So bulb gives radiation on all sides.
But the planet, only half of the planet faces the sun, sir.
Of the planets, but sun is Earth is only irradiation. We are talking about irradiation on the surface
Okay.
of the sun. So it's on the sphere.
Entire.
So 1368 times 4 pi times r squared, what is the number? Okay, that is the total amount of watts that the sun is giving free. Okay. Now let's assume the sun is a black body. So if it is a black body, what is EV equal to V? Assume a black body, electricity is equal to 1. So black body is W, the total power that the sun is emitting here. The power will be sigma times T power 4. So now let's calculate what is T out of that one. So you have W, whatever the number you have got, that should be equal to sigma times T sun power 4. So tell me how much is power 4. This you want the calculator because you have to calculate the 4th root of temperature. So whatever the number you got, the watts, you say whatever some huge number divided by 5.67 to the power of minus 8, which is converts one constant, and the 4th root is what? basal calculation session. What is the calculation form? Yeah.